Hello everyone, welcome everyone. Good morning, good evening, those who joining from West Coast, and I'm Madan Mohan. And just brief about me. So recently, I started working on a platform which works on predictive analytics and provide a lot of recommendations based on the consumer personas and activities. And the platform we call it as a ProKavi. So basically, we started exploring for a reliable and distributed connecting system or a messaging platform 8 months back, and after having a lot of discussions and after having a lot of insightful analysis, we felt Apache Kafka was a natural fit, and we just tried to uh, work on Kafka for last 8 months, and we are super excited with the kind of features and the kind of scale capabilities it was offering, and it is still going good for us. So what we're going to go today is I'm going to briefly talk about Apache Kafka and our learnings in the last 6 to 8 months. And I should thank Edureka to providing the medium to share our knowledge, and we'll all just briefly touch base about in the next hour or so. Okay, so if time permits, I may just quickly run through a demo in the last 5 minutes. So briefly, what we're going to cover today in the next 1 hour or so is basically get a basic understanding of what Apache Kafka is all about, what's the buzz about this messaging platform, and briefly talk about the high-level architecture and the components of the messaging platform, and what are the different ways you could use Kafka for development or for production use. And also, we may also try to contrast Kafka today with the most top contenders like ActiveMQ or RabbitMQ. And also, as I mentioned, we're going to just briefly run through a small demo, if time permits, at the end of this session. Okay, great. So, as you guys might have just watching for the last few years, the biggest thing which is getting adapted by majority of the smart world of electronics is all of the Internet of Things, the big data stuff, the NoSQL stuff, a lot of applications and a lot of things happening, and where everything depends on the data. So today we have the capability of capturing every human interaction with computers, or every human interactions with electronics, or the change of the state in the electronics or in the computers. So we have the capability today to monitor and capture and aggregate all the activities which is being changed in the computer systems or in the electronic systems. So what we can do potentially with these kind of capabilities is basically, say for example, a user interaction with a internet applications, like the user's login times, the logouts, the pages which is visited, the clicks, the component clicks, the duration of stay on a particular page, where the user has entered and where they are exiting, and various other touch points. Just imagine if there are, say, 10 million users who are visiting on a particular internet applications, just for a hypothetical case, right? So you would have, say for example, roughly say 100 to 150 pages. So just imagine the kind of the exponential data what you can gather on the activity of a particular user and the patterns of a particular user. So the data activity and the data growth is enormous in a day's time. Imagine if you have, say, multiple systems and multiple components and all the users interacting with all those things, the enormous data and the activity history what you could capture is, it's limitless. So these are all one of the scales of the data today, how it is growing into the world, where you could just get lots of data activity from a user to a system or a computer or a electronic device. Apart from that, as I mentioned, you could say, for example, today we have the capability to go and capture every phone record or every call records of a mobile user, from messaging to voice calls. So all those things are possible. So most of the mobile network operators today, they do capture all this information of the user activity on a phone or on a messaging platform. Apart from that, you could also have noticed, so when you have a DTH connection or a set-top box connection, even today, every event, every channel you watch, every channel you change from which channel to which channel, it is being jumped, it is captured on the back end. That is what we call it as user activity history. So these are all the kinds of things what people are doing as of today. And also you could also think of, say, social networks where people are trying to track what you're doing on a certain place. Say for example LinkedIn, who is recommending who, and who is getting connected with whom. All these kind of activity histories being fed as a news or fed as a feeds. All these things are happening in today's world. Apart from that, there are other things where systems monitor the infrastructure applications or the systems itself. For, say for example, simple monitoring, health checks, alerting, all proactive monitoring and alerting. These are all the kinds of things which is happening in today's world, where the data aggregation and the data collection for any activity of a system or with a human interaction with a system or an electronic device is being growing in today's world. So being said that, what is the biggest challenge when the data activity or the data aggregation is being uh, grown? So one of the biggest challenges with the increasing data activity history or the data growth is how do we connect all this increasing data which is being populated by various systems and connect it to the right channels or connect it to the right place where the data can be processed and the data can be used for all the useful needs of the business. So in this critical world, if we don't leverage this kind of a data, the business at the cutthroat competition, you will be always losing the business in very few years. So these are all some of the challenges where you have to increase your revenues, you have to increase your quality, you have to increase your security optimizations and all your product offerings. So this kind of data, the secondary data, has become the primary data in most of the production systems as of today. So this kind of data has been very critical for long time, but today, since we have the capability, the challenge has come where we need effective messaging systems or platform which can capture the big data generating sources and try to analyze and present all the rightful information to the rightful sources at the right time. So that's the primary challenge, and that's what has been people trying to do with various systems. With lot of success and challenges, people managed it so far, but there was always a need which can do, say for example, real-time messaging, or where we can do multi-point connections using a platform which is very efficient to scale to the big data needs, where the real-time data is being real-time data or stream, or people do call it as stream data, or people do call it as activity data. So all these aspects has been challenged and people used to manage it in one way or the other way. Okay. uh, So what I'm going to do is maybe one or two questions I would take it in between, but most of the questions I'm going to park it at the end. Kafka is not just for instrumentation and capturing the data. It is a messaging platform where it instruments and collects data from various sources and acts as a message broker to giving it to various other consumers. So we'll discuss about all these things. Once you guys go through all these things, it would be pretty much easy for us to understand. Okay. Okay, so let's also briefly talk about few real-time analytics. Say for example, so let's also briefly talk about some of the real-time problems where we had, say for example, most of you might have noticed the ads on Google Ads, where the moment you show some interest on a particular product or a service, your ads follow you even after you leave a particular asset. So all these things are captured at real time. So this is again a very good example of activity being captured at real time and process and pick the right ad and serve it to you. This is the mass systems where people target on all these things. And also, if you could notice, there are online book subscription sites where they try to restrict based on your pattern of your consumption. Say for example, if a user or a bot is trying to consume a lot of data within a very short span of time, they usually go ahead and restrict and say maybe you are not trying to use this content or material in the right way and I'm restricting you. These are all the kind of activity which is being really captured at real time, and they are trying to put restrictions based on your usage or based on your pattern. And also you would have noticed where there are few search relevant sites where they do go ahead and make autocomplete recommendations. Say for example on Amazon or Flipkart, the moment you type something, based on your typing they go ahead and predict some of these things. If this is the kind of thing you are trying to type, this is most likely that what you're looking for. Maybe there are some sites even they do provide recommendations on their sites based on what you are trying to search. These are all the real-time activities people try to capture, and they are trying to manage all these things. Okay, so as we just discussed, to manage and provide these kind of features, we said connecting all this incoming information and trying to give it to a different systems, it is kind of a huge challenge. In older days, we used to have most of the time a point-to-point system where there was a system which used to generate some event, and ideally that goes and sits into queue, and there used to be a consumer where it consumes and processes that particular message or a item. In today's world, that is no more a case where you only have a point-to-point system where there is only one producer or a one source who is generating a message and only one consumer who is going to consume it. Today, the world is of all uh, microsystems and heterogeneous distributed systems where there will be multiple systems which is generating items or events or messages, and at the same time there will be heterogeneous distributed systems which are trying to consume the events or messages from various sources and trying to analyze that and trying to make the business decision or business information. So the world has changed drastically. From a point to point messaging, the world has evolved into a multi point to point where the data has to be routed or managed to through different systems. Because of all these things, a biggest need to have a proper scalable or a highly scalable distributed messaging system was the requirement. Okay, so if that is the problem, so it has to be highly scalable. It has to be properly distributed for big data needs. If without distribution, you cannot have a big amount of data coming in and can be managed within the messaging platform, and also like failovers and various other aspects. So this was the solution which people were looking for, having a very good platform, messaging platform where they could use it for multiple points to multiple points connection. So the answer, uh, at least for this session, seems to be pretty natural. It's going to be the Apache Kafka. So with so much of data coming in with all these kind of challenges, so we're gonna make a recommendation. Apache Kafka fits the bill in this kind of scenarios. So let's see what exactly Apache Kafka is all about and what's the buzz going around this. Okay, so I'm just reading some of the questions just in case if I have to take any one of them, which seems to be interesting. So let me just see. Srihari has a question. Can you please provide a real-time example which you use so that we'll get a clear picture? Okay, I'm gonna share one of my examples at the end for sure, which I'm using it in my current project. So we will definitely, I'm gonna definitely share that at the end for a couple of minutes. Okay, So Apache Kafka is an open source. I'm just giving you the uh, documented definition of what exactly it is, and then I'm going to describe what it means. Okay, so it's been documented, it's been said that it is a message broker, and times they do also call it as a publish subscriber system. So don't get confused with a publish subscriber system, which we traditionally used to call it, where there is a publisher and there is a subscriber who is always trying to consume the messages. It is a publisher subscriber system in a different design sense. Okay, and also it is called as a message broker platform. Okay, so you can use it interchangingly. Okay, so currently it is under Apache Software Foundation and it's written in Scala. So those who are interested, initially it was developed under the few developers in LinkedIn, and then it got moved on to Apache Kafka, and the people who developed under LinkedIn, they moved to form a different team called Confluent. So that's a history of how Apache Kafka evolved. So as we discussed the challenges and the problem statement, and we said we need something like this. So the people who developed Apache Kafka at LinkedIn really faced a lot of challenges with the existing systems, and that's the reason why they went and developed this kind of a system on their own. So when they started the development, the project intention was to have a unified distributed messaging platform which has a very high throughput for say millions of or billions of messages per day, and also had a very should had a very low latency for all publishing or consumption, and it should really handle the real-time activity data stream from different systems. So this was the objective on which Apache Kafka was built. Okay, so basically they picked up a design approach which was heavily relied or heavily dependent on the concept of transaction logs. Sometimes we call it as transaction logs or commit logs or write ahead logs. So this was a concept which is very efficient because of all the disk effectively used techniques. So the commit ahead logs or the transaction logs uh, are primarily used in most of the transaction or OLTP based system to record all the changes or events which is happening in the OLTP databases. So this was the technique which most of the databases or NoSQLs use it to make it their data consistent. So the same approach or the same technique has been adapted by the Apache Kafka designers to make it consistent and make it persistent in the data which the messaging platform supports. So by doing that, they also focused on the distributed aspect of Apache Kafka, which should be which should not just run in one single machine, but potentially it should run on multiple machines with a cluster centric design, where if you run on distributed machines, then eventually the partitioning challenges comes into the play. So the partition is, if you have a huge data set in your cluster, you cannot keep that entire dataset cluster in one machine or in a one node. So you have to partition that based on some strategy or on some key strategy. So then they have to build in that partitioning, or they have to build in the distributed aspect of the Kafka. So they started thinking of how do we have distribution. So one of the ways is having the partitions on the data sets or on the messaging topic or messaging queue. So that's how they can do the elastic aspect of the need, so that when you have partitions and when you have distributed nature of your cluster for messaging, you can elastically grow the system, and it will be also highly available with lot of various aspects. And also they have thought about this highly throughput. So once they have lot of machines with lot of data partitions, so a data set can be published or can be consumed from different machines. So that way you can get a high throughput rather than everything running in a one queue or everything running in a one node kind of a system. So also Kafka provides persistent messaging. When I say persistent messaging, the data is persisted into the transaction log kind of a file system, but most of the time it is being served from the cache or the OS cache or the disk cache. Why Kafka becomes a little bit more efficient in the reads or writes on the messages. Okay, so also as I mentioned, Kafka is a system which has been built and used for real-time needs, and it do provide a lot of things which is really fast, scalable, and since the data is persisted on the disk, so it is durable that even it can sustain the system or few node crashes. Okay, fine. So let's briefly also talk about the little bit design or the architectural aspects of Kafka. So Kafka primarily has 5 components in the cluster. So the first one is Zookeeper. Zookeeper primarily is used as a configuration and the registry index kind of a service. I'll just briefly talk about Zookeeper as well. And the second one is the broker, and the third one is the topic. The fourth one is the producer and the consumer. So a topic is nothing but, like many other publish subscribe messaging system, it maintains the messages or the bunch of messages in its repository. Okay, so topic, I think you should guys are all very familiar about it. So Kafka also uses the concept of topics, but the topics can be partitioned and distributed in multiple machines. That's the difference. And the producers are the ones which processes and publishes the incoming message or the activity data to the broker or to the cluster, and consumers or the processes which subscribe to the topics and pull all the messages or the items or the data from the topics. So I'm using the word pull. So in some systems, the in some publish subscribe systems, the data or the messages or items are pushed to the consumers. In Kafka, rather, it is being pulled from the consumer. So eventually, the brokers is the cluster or the servers which holds the topic or which holds the messages in the cluster. So these are all the 5 basic components which Kafka uh, architecture or the cluster has. And what happens is, basically, let's start from top-down approach. So the producers send the messages over the network to the Kafka clusters or the brokers which has been installed or deployed, and from the brokers or the topics, the consumers pull all the messages from the topics of their interest. Okay, so all the communication in the Kafka cluster happens over the if it is a production system, it happens over the TCP protocol, which is the standard or the de facto of today's interaction or the networking. Okay, so guys, I see a lot of questions, but due to a lot of time constraints, so we may have to take a few of the questions at the end, or what we're gonna do is we may have to record all the questions and we have to take it offline to answer some of your questions. So at the end, I'll at least manage to have 2 to 3 minutes to take very important questions. Okay, so please feel free to stream all your questions, and we will have to park that for a while. Okay, great. So we're going to talk about these components in detail a little bit. So what we're going to do is, once we get into the details, we'll be much more clear and much more confident about these things. Okay, Fine. So let's briefly talk about the Zookeeper component, what we saw in the architecture. So how is Zookeeper related to Kafka? So Zookeeper is an independent Apache project which Kafka recommends and incorporates for its internal use. So again, as I mentioned, it is an open source project which is highly available system primarily used for coordination and lookup service as a registry index in a distributed system. Say for example, if there are so many systems and components in a platform or in an architecture, it becomes very hard if you hard code, say for example, an IP address or a host name for 3 to 4 services. What happens if that host name or a IP address goes out of service? So there are various different techniques. Say for example, people used to use virtual IPs or active standby or heartbeat techniques in older days to in different ways to manage all these active standby. But in modern application architecture, people started using the Zookeeper as a configuration and lookup service. Say for example, if there are 10 to 15 servers, and at any given point of time you need to know to which server you wanted to talk to for a particular service to consumption. So Zookeeper can keep track of all the nodes as Z nodes, and it will try to monitor and say if a particular node goes down, it marks it as down, and it can give any one of the nodes which is available from that pool. So these kind of things is what Zookeeper offers. Okay, yeah, it's kind of a node manager where you can also store configurations. Say for example, instead of keeping the configurations of a system or a distributed environment in your application or in your property file, it may be efficient if you store it in a distributed platform where that can be dynamically changed or where that can be programmatically changed. So Zookeeper offers you this kind of flexibility where you can read the configurations or the service lookup from a distributed system where the Zookeeper offers all those things. So Zookeeper is also like a very quick uh, index or a quick access, cache access where you can get all these things. Okay, great. So little bit more about Zookeeper. It also provides centralized configuration. It also provides your locks. Say for example, if you have active standby, it elects one of the nodes as active and it marks one of the nodes as passive. So all those things say the naming service or the registry lookup. So what Zookeeper plays here in Kafka is basically it serves as a coordination between the nodes in the entire cluster. So even a publisher can interact with Zookeeper. The brokers or the cluster nodes can also interact with the Zookeeper, and at times even the consumer can interact with the Zookeeper. So there are various needs why they interact. I'm not going to the details of it. I'm going to briefly just touch base and skip on over to the next things. So primarily producers use Zookeeper to identify the lead broker. So most of the time the producers interact with the Zookeeper to identify if there are one too many brokers in the cluster. We said broker is nothing but a node in the cluster which owns the topics. Okay, so if you wanted to know which is the lead node, because Kafka publishers or the producers try to interact with the lead broker, and remaining and all becomes the followers or the follower nodes. So what happens is most of the producers try to interact with the Zookeeper to identify the lead broker in the cluster. So that is one of the reasons why we need the Zookeeper. And when it comes to the brokers, what brokers does is when there is a lead broker identified for a topic, okay, and as I mentioned, uh, Apache Kafka also provides high availability by duplicating the data or replicating the data into multiple nodes or multiple brokers. So in that case, what happens is there is a lead broker and there are following brokers. So the lead broker takes the responsibility to own the content, and there are following brokers. Say for example, if a lead broker goes out of service or it dies, immediately there are following brokers which becomes the lead. So there is no concept of master slave or a master master kind of a thing. They're all peers. at any given point of time, zookeeper interacts and zookeeper takes the responsibility of electing a lead broker. So that's the reason why would you require a brokers interacting with zookeeper. And also the brokers persist the message state into the zookeeper so that everyone is in sync with the message state. So that's another way of interacting with the zookeeper from the brokers. And also the consumers retrieve a particular topic's state from zookeeper to retrieve to which brokers they can reach and consume the messages. So these are all the interaction touch points in the uh, Apache Kafka with zookeeper. Okay, fine. So let's briefly talk about what are all the different ways you could potentially set up the Kafka cluster and how you can leverage the Kafka for various use cases. So primarily there are three modes which you can use it based on your use case and your requirement. So the first one is the single node, single broker cluster. The second one is the in a same node you could have multiple brokers, and uh, uh, the last one is multiple nodes, multiple brokers cluster. So just by looking at it, you might just wonder uh, what are all the different use cases of having this three modes. So we're gonna just briefly talk about that as well. Okay, so in most of these aspects, we're not going to touch base on how the zookeeper is eventually being set up. The zookeeper will be eventually treated as a different entity, or it's up to you how you wanted to manage the zookeeper, because it's that itself is a different component, and that itself is a different aspect altogether. Okay, so what we're going to do is, let's see the first mode of doing things, a single node, single broker cluster. So in this, basically is primary. Most of the time, it would be useful if you are trying to build an application, or if you are trying to learn Kafka. So this is the ideal mode where you can have a simple virtual machine, and in that single virtual machine, you could have all the components running in the same virtual machine. So those who are familiar in Hadoop, even Hadoop does more or less a similar model, where it has a standalone or a pseudo distributed mode, or a production mode which runs in a fully distributed mode. So Apache Kafka also adapts the same technique or the principle, where all the components or all the processes run in the single node. Okay, so Apache Kafka also comes with a very simple and clean configuration management, where it does support all the configurations or all the properties required for us to run the entire cluster in a single node, single broker cluster architecture. So primarily, if you are planning to run this in a single machine, all of these components, what is that you have to do is, primarily in Kafka, you have options to start all these components individually and run all of them as a different process. So the first one to run is your zookeeper, and then you could start your server or broker, and then you have to create a topic, and then you have to start a producer and start a consumer. So these are all the steps what you have to do if you have to run your entire single node, single broker cluster. Okay, so once you finish all these things, you are ready to publish and subscribe messages between your producer and your consumer to whatever the topic you have created. Okay, Fine. So let's also briefly touch base on the different mode, the single node multiple brokers, and this, let's briefly touch base on how does this happen, and also that should clarify some of your questions which I briefly had a glimpse, that whether a broker uh, will hold all the topics, or how the topics are partitioned, or how the producers would have a call. In the earlier model, there was no option that all the topics would have been created on a single broker, and even though you couldn't had an option of replication factor, so by default you wouldn't have any failure or nothing. So it's a very simple model, so you didn't have to bother about lot of things. But in this model, at least we have an option to configure multiple brokers. So when I say multiple brokers, you could have more than one virtual node in the same machine. So here we can have more than one brokers. Let's assume if we have three brokers. So the process or the steps for us to run the cluster in this mode more or less remains the same. Instead of, after you start the zookeeper, instead of starting just one broker, we have to start three brokers with three different set of configurations and with three different set of port numbers on the same machine. Say for example, once you have started the three different brokers, remaining all of them, all the steps remains the same. Okay, now let's briefly touch base on what exactly is gonna happen. Fine. So let's assume we have created a topic, and that topic potentially is partitioned onto broker 1 and 2, and based on the partition, the partitions most of the time work on a key. So based on the key, the producer either it can interact with broker 1 as a lead for that particular replica set, or broker 2 as a lead for a different partition or a replica set. So this is how a producer will or can interact with different brokers based on which broker it has to interact. Say for example, for a topic, broker 1 could be the lead, and for a different topic, broker 2 could be the lead. Or for the same, topic, for a different partition, broker 1 could be the lead and broker 2 also could be the lead. This is one of the scenarios where you could have all of them interacting to all of them. Potential possible case, but not necessary that one producer has to interact with all the brokers. It all depends on your topic, your partition, and your replica sets. So all these things are retained in the zookeeper. The producer queries the zookeeper based on the key and the topic and tries to get to which broker it has to interact for that particular topic. Okay, so there are a lot of questions, guys. I'm sure these are all questions which we will take care for sure. And when it comes to consumer in this mode, the consumers, the first point of interaction is with zookeeper. And say for example, a consumer is interested in a topic. If there are two topics in the cluster, the consumer first has to know to which brokers it can go ahead and read the content from. So the first point of contact is zookeeper, because the brokers has shared the topic information and the topic state in the zookeeper. The consumer interacts with the zookeeper and tries to get the state of that particular topic, and thereafter it tries to reach to the brokers to fetch the messages. It pulls the messages from the brokers or the cluster. So the another one good difference from traditional publish subscribe model is, in Kafka, the consumers avoid continuously polling or continuously pulling the messages, just to avoid the overhead of whether there is messages or not. What it does is it goes and gets the messages based on the topic offsets. So every time the consumer is responsible to retain the offset from where it has left reading, and it passes the next set of the offset from where it has left, and it goes and picks the information. So this is how the single node multiple broker cluster works in a very high level. So there are a lot of internal nitty-gritties or details which goes inside. Since this is just the introductory session, we're gonna touch base very at the high level. Okay, and also the producers can send the messages in batches. Most of the systems or most of the messaging platform lack this capability where they cannot send the messages or the data in batches. Kafka is really good in uh, bundling the message batches when there is real-time data coming in, which helps in lot of network latencies or lot of round trips. Okay, so that's how the single node multiple cluster happens. Okay, great. So let's briefly also touch base on the multiple node multiple brokers model. So primarily this kind of a setup is recommended for production use, and this is the way how you could have any number of partitions, any number of topics for your scalability needs, and with high availability and failover with replication, and with say replication factor of 2 or 3, identified is the basic requirement, identified basic recommendation is like say 3, and even if there are 2 nodes which goes down, still your data is safe and it provides the high availability. With this kind of a model where you could read the same topic from multiple brokers by the same consumer, it increases the throughput of your incoming items or your processing capability. Okay, and also since it also persists the data in a transaction log format, your entire messages are durable even during crash, or it is persisted for a certain point of time so that you could use it within the window. So your messages are never lost. Primarily, there are few things which I'm not sure whether I can jump into the things. You can run Kafka in a different configurable modes apart from these. So there are modes like whether you can get a message or it will be persisted. So there are few techniques or few configurations where you fine tune the entire model of Kafka itself, can be fine tuned or it can be augmented in a very small way. So in this model, most of the time it is recommended that you have lot many machines and run uh, all these processes or all these primarily the brokers on different machines or on different nodes. So in this model, let me just briefly also touch base. The producer publishes the message to a particular topic partition, and that particular topic partition can be placed on any machine. It could be on node 1 or it could be on node 2. Now here in this model, the topic which we say, for example, if we have created a test topic, the test topic data would have been distributed on node 1 and node 2. Potentially node 1, there would be the test topic messages on broker 1 as well as on broker 2, because the broker 1 could be having a message, say message ID 1, and a replica of that would also be stored on broker 2 possibly, or it could have been also stored by broker 1 in node 2. All those options are possible because all these things are required to support the high availability. And as I mentioned, the consumer follows the same technique of interacting with the zookeeper and identifying to which broker it has to interact to get the data from the broker or the clusters. So primarily in this model, replications supports the failover, and all the lead broker management, everything is handled by the zookeeper. Okay, great. So let's briefly talk about one of the interesting use cases. So most of you would have noticed that we we get LinkedIn activity news feeds where uh, LinkedIn shows us user information about who has viewed their profile and who has been searching for them. We have seen all these kind of things, right? So for us to get this kind of information, LinkedIn uses internally Apache Kafka to stream all the activity history and provide all these insights in near real time. So LinkedIn trains their machine learning models against all the activity and the user interactions with the system, and it tries to predict the connections of, say for example, if you are doing this kind of activity, maybe you should try to say look at these people, right? Maybe these are all the job matches which matches your activity. Maybe they optimize and display similar profiles or similar jobs or similar companies who are working based on your activities. So these are all the things what LinkedIn uses to make recommendations or the content, but eventually in the backend, it relies heavily on Kafka to connect all these systems for processing and analyze and present this information. Okay. And also there is another very popular feature on LinkedIn where Kafka is heavily used is on the activity driven news feed based on the relevant occurrences in the social network. So there is a news feed which keeps on coming, who is doing what in your circle, what happened with whom and all that stuff, who got connected with whom. This is another feature which heavily requires the data activity stream processing and being able to present this kind of information. Okay, so LinkedIn has roughly, I have just read and captured some data metrics or data points from LinkedIn. They have more than say 200k, 300k messages per second, which evolves from various different sources, and they have to connect it for processing or for connect it and store it for later processing. So they claim to say that the excess of more than 40 to 50 billion messages are delivered on a real-time basis to the consumers based on various different aspects. And they also store this entire activity history in Hadoop for later analysis or later processing required for various other aspects or various other needs. Great. So fine. So apart from using it for their functional needs, LinkedIn also uses Kafka uh, primarily to do a lot of system monitoring, application monitoring, and uh, providing all the uh, application and system metrics to the businesses. Okay. So I think we spoke a lot about LinkedIn. So I'm just gonna briefly touch base. So apart from LinkedIn, there are bunch of people, I think, including my own company, who started adapting Kafka. There are a bunch of companies which you guys can go through. So there are few people like DataSwift primarily uses to collect all the social behavior or the social activity of a users, and they do provide a platform or a API access for businesses to analyze and consume that kind of a data. Like similarly for Uga uses it for all their games hosted on Facebook, how things are going and all those kind of stuff. So I'm not going to touch a lot of details about it, but I think you guys can always uh, go and check the link where you could find loads of use cases. And one important thing I would like to touch base is the Logly. I think I've used Logly a while back. It's a beautiful platform where it provides a neat framework for all your log management and reporting needs. So even Logly uses the Kafka for backend log collection and log movement to the processing center. So these are all some of these things. Great. So I think we have got few minutes. I may just stretch for a few more minutes beyond our scheduled time. So so we had few questions like how about ActiveMQ and what about RabbitMQ? So I'm not gonna do a bashing session on ActiveMQ or RabbitMQ. Rather than what I'm planning to do is I'm gonna briefly share the differences which I'm aware of so that we could just try to do a contrast of it. So as we mentioned, ActiveMQ is a really great feature-rich platform according to me, and it has been built on the AMQ uh, protocol, and it is a very rich platform with lot of features where Kafka cannot compete with the features of what a ActiveMQ offers at this point of time. So comparatively, Kafka is very new. It is not even version 1. It, if you try to compare the documentation aspect from ActiveMQ to say Kafka, I would say ActiveMQ would win hands down. So there is no comparison. But when it comes to the scale and when it comes to the throughput, Kafka really outbeats say ActiveMQ in some aspects. And also, I would also state ActiveMQ is a real contender or competitor to RabbitMQ rather than I wouldn't put a head on with Kafka at this point of time. So some of the other things what I could think of ActiveMQ is basically ActiveMQ uses a similar technique of brokers, uh, but it uses a mesh architecture of brokers where you connect to one of the members and publish or consume that message. So one of the beauty of Kafka is it is a non-blocking publish subscribe compared to some other techniques which is like a blocking publish subscribe methodology. Okay, so one more difference I could think of between ActiveMQ and Kafka is basically in ActiveMQ, basically you don't know what is the node and for a particular queue or a topic, what is the node you have to locate and how you have to route the messages. So everything is taken care by the ActiveMQ. At times this looks very simple. Why do I take the overhead of going and figuring it out with a zookeeper? Who is the leader? All I'm bothered is I have a mesh, I'll contact the mesh, let it do the work for me. But if you take out certain responsibility of doing it for yourself, there is lot of architectural and the complexity of computing becomes simpler on the cluster or on the server. These are all the few things which I could think of between ActiveMQ and Kafka. So I'm not gonna run through about RabbitMQ, but RabbitMQ, I think that's the one closest which comes to Kafka. Again, it is feature rich. You cannot compare the features of RabbitMQ or ActiveMQ to Kafka. I would say RabbitMQ is still a very popular and preferred solution. If you have a message pattern which has to be routed based on some conditions. So in those cases, yes, RabbitMQ plays a very good tool. So I wouldn't prefer Kafka if you have to choose that based on some conditional routing. So these are all some of those things which I could think of, but I didn't want to bash one thing over the other. That's the reason I've been trying to be objective and trying to contrast things. Okay, fine. So let's also try to quickly check. LinkedIn done a very good benchmark testing on the Kafka versus other platforms. So basically they did a producer test. So the screenshot what you're looking at, uh, is basically the producer test. So the first test, basically, if you notice, the Kafka without batching, you might see that it almost just stays little ahead of RabbitMQ and ActiveMQ in the throughput. When you do the batching, when you club the items or the messages in a batch of 50, that's where you could see exponential growth on the throughput from the producers. So the what it means is basically it is recommended, if you do the batching in the messaging from the producer, you would have the throughput which can be exponentially increased. But being said that, we cannot just ignore the fact that the other systems does not provide the batching. So if you compare one item or one message versus ActiveMQ, Kafka, RabbitMQ, you would see Kafka still stays ahead, but not that significant. But when it comes to the batching of the messages, you would see the exponential growth, which is more than what you could think of. Okay, so apart from that, there are some disk overheads. Kafka seems to be a little bit more efficient on the storage format. On an average, it saves around, say, 140 bytes. So that seems to be very little. But when it comes to the volume of, say, millions of messages per day or per hour, that could be your significant overhead or the significant cost factor. Okay, so let's quickly jump on to the consumer test. Similarly, I'm just briefly going to talk about the consumer test. So consumer test, I think you should definitely see the Kafka just outstands everything because it reads the topic from various different brokers. So that is one of the reasons where you see the throughput or the consumption aspect compared to any other system, Kafka outperforms, and there is no any apples to apples comparison here. So I would just straight away give uh, Kafka the natural fit when it comes to the consumption test. Okay, great. So now we have reached to the end of the things. As I promised, I'm gonna briefly show you the hands-on demo of just how to run the I'm just gonna minimize everything just to complete the exercise of what we have. So let's have, I have already opened 5 terminals, and what I'm going to do is, as I mentioned, the first thing is I'm going to start the zookeeper. Okay, so for that I have to change to and start the zookeeper, and similarly I'm going to do the same to start a broker. Okay, so I'm going to start a broker. So yeah, I have started a broker. So what I'm going to do is, once I've started the zookeeper and the broker, I'm just going to go ahead and create a topic for today's test. Okay, so I have created the topic called Edureka seminar topic, and it got me a message saying back the topic has been created. So once I have created the topic, so let me just go ahead and check what are all the topics. I'm just trying to, or I'll just ignore it for a while. Okay. Um, okay. This is just to, okay, make sure we have everything fine. Just to make sure the zookeeper and the consumer and the broker, they're all synced up. This will make us sure that everything is working fine. So this at least now the broker, the zookeeper and topic has been created. Now we can start the clients. So there are two clients. One we have to start a producer to publish the messages and the other one for consuming the messages. Okay, great. So now we have the producer ready. So let's go ahead and start the consumer as well. Okay, fine. So the simple check what we're gonna do is we're gonna go ahead and type something and say welcome to Apache Kafka world. So you might have noticed you would see the consumer already consumed that message. So every line treats as one message and say hello Edureka. Let's type that. So you would immediately see that message has been consumed by the consumer. So this is the very high level quick demo of things, how things work, so that we could just get a first hand experience in a very short span of time. Okay, so let's go back to our desk, and we do have a few reference material which we have used in this presentation, so feel free to just go ahead and access this content and do check. Couple of things I would like to share before I get into pick couple of questions. So I'm going to do that, and also I'm going to share my use case for what I'm using Kafka for. Okay, so please make sure you provide us the feedback. I know it's been very cramped and it's very uh, quick in a short at very high level, quick paced. So that's where the sales pitch comes in, guys. So we do have a course which starts on the coming week, hosted by Edureka. So it's a 5-week course which we will get into the details of it, and we will have much more time to leverage all these things. Okay, so now let's jump onto the questions. So what I'm going to do is I'm going to pick the two questions which I could potentially answer, and what I'm going to request the Edureka support staff is to make sure they uh, persist all these questions and get back to you offline. Okay, great. There is one question. Edureka says 2 weeks. Is it 5 or 2? Can you clarify? It is actually 5 sessions, 2 weeks, or 2.5 weekends, in fact. So both are right. Okay. Anwar has a question. So what is the prerequisite to take this course? So there is a slight requirement that you should know basics of Java. And anyways, we're going to cover some of the basics of Hadoop and other things if the course requires so. So the prerequisite is Java, and we do have a complimentary course on Java. Once you sign up for that, you would be recommended to go through Java, so that when we do the Java programming, it would be much more easier for you to follow, just in case. Okay. Okay. So as I promised, the last question what I'm going to take is my own organizational use case. So this is a startup started by me a year back, and what we are doing is basically we monitor and capture the every product the users or the consumers has, and we are trying to capture the user activity or the behavior with that product. So you could imagine the amount of data what we could get potentially from that. It is a slightly a concept which relates to IoT of things, but in a different way. So since it has got a lot of IP information, so I'm not going to share the entire details till we launch it. But the idea is we're going to capture every user activity with a product or with a service, and then we're going to analyze and provide all the recommendations or all the insights to the consumers that what is the next logical thing you could potentially do with your product or a service. So that is the entire thing what we are trying to do. For us to do that, we have multiple systems. So we do have more than 17 to 18 microsystems. Within that 17 to 18 microsystems, I could just briefly show you guys, I don't mind. So here is the we have wrapped the entire Kafka over a microservice, and we do use the Kafka as a microservice and publish all the events coming from all the products or services from the mobile handheld devices, and we are publishing it to various processors. One of the processors I could think of is, say for example, I have immediately went and purchased something. So I immediately notify a controller or a consumer that I have purchased a product, and you have to archive the invoice of what I have purchased, and you have to analyze the details and send the reminder for the next renewal to the consumer when the date arrives. So those are a lot of scenarios or lot of things what we have done on the um, app basically. So I am sure, I think we also used same Apache Kafka, some 8.2 version. Yeah. So we have used 8.2.1, which is just pretty recent one. Okay. Being said that, I hope you guys enjoyed it, and please feel free to give feedback, recommendations, or whatever you guys think is good, bad, ugly. So we are all open to all your questions or recommendations. Okay, great. And I have to rush. I have got another meeting. And good night and good morning, guys. And we'll see you soon. Bye. Bye.